Hey physics students, so we just have a quick problem regarding Coulomb's law that I wanted to go over today. It says a particle with charge q is located at the origin and a particle with charge 5q is on the positive x-axis, a distance d from the origin. The particles are not free to move. In terms of q and d, at what coordinates should a third particle with charge q be placed so that it experiences no net electrostatic force? Assume r is the location of the third particle away from the origin along the positive x-axis. So here we have a problem-solving guideline, and so the first thing when going through a problem-solving guideline that we want to look at is what are the main concepts that the problem deals with. And so in this problem, the main concepts are, we see there Coulomb's law and electric forces. And these are introductory concepts that you'll learn in chapter 23 of our text. And then the next thing that we're going to look into is what is our given information? Is there any hidden information? And in this problem, it's just that the force on one object is equal to the other object. So we have an object with a charge of 5q and another object with a charge of q, and these forces are going to equal out when they're placing a charge on the third object. So the final quantity that we're looking for is r. It's that distance that we talked about in the problem. It's going to be in terms of d and q. Next, we want to predict the range of possible values. What distance could r be between in terms of d? And so in this case, r it's got to be greater than 0 because it's got to be somewhere on this interval, and then it's got to be less than or equal to d. It's not going to be greater than the interval. And so our picture is really simple. We just have one charge. This is our origin. Then we have the charge with 5q. And our bonus q is going to be somewhere in the middle here. R is kind of arbitrary at this point. We don't know what it'll be, but it's some length. And then the total distance here is d. Next up, we just need full equations to solve for the unknown quantities in this problem. So in this case, there's just one. It's just f sub q equals kqq, over r squared. That's part of Coulomb's law. When we show our work in variable form, it doesn't reduce a whole lot. We have the same equation. We have one for our first charges, the charge from the origin, and then we have our second equation for our charge that isn't from the origin. So our first one is just the f of our charge of 1 on our second charge of 1 is just qq over r squared, and then the second one is the charge with magnitude 5 on our additional charge of 1, and for that it's f sub 5q equals k times 5qq over, and that's d minus r squared, and the d minus r squared is because when we look at our total distance, we have d, and then we have to subtract whatever our arbitrary length r is, and we'll end up squaring that quantity. And the above one, the r squared is just the distance from the origin. So working out our problem in steps, it's kind of a long one, but we set both equations equal to each other. So kqq over r squared equals k 5qq over d minus r squared. And then this quickly simplifies down to 1 over r squared equals 5 over d minus r squared. You can see over here that the q's and the k clearly cancel each other out on both sides. In fact, you can just cross those guys out. So that is just 1 over r squared minus 5 over d minus r squared. By our rules of algebra, we see that d minus r, multiplying both sides by d minus r squared and the other side by r squared, we see that d minus r squared equals 5r squared. Expanding the exponential here, we have d squared minus 2dr plus r squared equals 5r squared. And then simplifying this all to one side, we have 4r squared plus 2dr minus d squared. And finishing it off, we see the quadratic formula. R equals negative 2d plus or minus the square root of 2d quantity squared minus 4 times 4 times the quantity of negative d squared all over 2 times 4. And this simplifies to negative 2 plus or minus the square root of 4d squared plus 16d squared all over 2 times 4. And that's equal to negative 2d plus or minus 2d times the square root of 5 over 2 times 4. Cancel all the 2's out. We get negative d plus or minus the square root of 5d over 4. And our final answer, where the particle's location would be, is the square root of 5 minus 1 times d all over 4. That is how far away from the origin in relation to d that our particle is.